So hello everyone, we are having this question with ourselves of limit. So we are just going to solve this question using LH rule. So let's solve this question. So let's get familiar with square minus of under root of 1 upon under root of 1 minus of 1 is going to be 1 minus of 1 upon 1 minus 1 is going to be 0. That means this is of 0 by 0 form. Okay. So this is of 0 by 0 form. So we could apply the LH rule over here. Okay. Now, according to the Selish rule, what it is said is that upper differentiation of the upper function and differentiation of the downward function is going out to be the same every time. It's going out to be if you really wanted to solve this question. Okay. Now just let's solve this. That this question is like limit x tending to 1. If you just wanted to just to differentiate this part, then x to the power n is equal to nx n minus 1. So if this is in this form, so what gonna happen is that 2n 2 minus of 1, which is coming out to be 2n to the power 1, which is similar to 2n. Okay, so we could write 2n over here. So 2n minus of x to the power half, we could actually write it, or what we could write it as to be half minus of 1. Okay, so let's solve it further. Limit x tending to 1 to the power n minus of this. Okay. Now if you consider this as to be n, then what's going to happen is that 1 by 2 x is what? This. And 1 by 2 minus of 1 is coming out to be what? 1 by 2 x minus 1 by 2. Okay, so for this part it is going to be 1 by 2, and we could write it further like, okay, it is x over here also x over here. Now you could write it in this form, 1 by 2 under root of x, because this and this both of them are similar, so we could write this in the format. So let's write it over here, under root of x upon, now this is same of this one, so we just don't need to differentiate again, we have to just put it over here, 1 upon 2 under root of x minus of 1. Okay, now just let's put the value, x to the 1 is equal to 2 into 1 minus of 1 upon 2 under root of 1 upon 1 upon my 2 under root of 1 minus of 1 is coming out to be 2 minus of 1 by 2 upon 1 by 2 minus of 1. But we forget that the differentiation of the this part is coming out to be 0. Differentiation of constant part is coming out to be 0, so we don't need to write anything over here. Okay. Now 4 minus of 1 is coming out to be 3 by 2 upon 1 by 2. So let's solve it further. 3 by 2 divided by 1 by 2 is coming out to be 2. 2 and 2 will get cancelled out. We would be lefting out with the answer of 3. So this is very basically the solution for this question, which seems to be very complicated, but by applying the rule seems to be very easy. So that's all for this video. Later we will be discussing the another part.